This is limiting reagent and percent yield. We'll start off with the concept that you guys will recognize pretty quickly, I think, is limiting reagent. This is going to take several videos to do. So if I want to make trucks, I start off, and I'm going to have a reaction that I'm making up, a truck body, which is the frame and the chassis and the fenders, etc. And I need 4 wheels. So I'm running this junkyard and I'm making vehicles, and I got truck bodies and wheels, and that gives me a complete truck. So the question becomes, if I have 100 truck bodies and 100 wheels, how many trucks can I make? Well, very quickly, people look at this and go, well, geez, we're going to run out of wheels first because it takes 4 wheels to make a truck body. What they're doing in their head is they're saying, I have 100 wheels, and I'm going to abbreviate that WH, and it takes 4 wheels per truck. 1 truck, so I get 25 trucks. And then we'll compare that to 100 truck bodies, TBs, and we note that it takes 1 TB to make 1 truck. And so I get 100 trucks. Now I can't possibly make, and people do this, but you can't do it, is I can't make 125. I'm running out. I can't make 100 because I'm out of tires, so I can only make 25 trucks. That means the wheels are limiting. They limit how many trucks I can make in this case. I'm going to run out of wheels before I run out of truck bodies. So the wheels are the limiting reagent. And the maximum number of trucks I can make is 25 trucks. So this is what's called the theoretical yield. Theoretical yield, and this is the limiting reagent. Limiting reagent. So that's what happens on this. Now let's expand our example. Let me erase. So we've calculated now that our theoretical yield is 25 trucks. Let's say you're working in the junkyard and you work for 1 day and you make 5 trucks. You actually make 5 trucks per day. So in any day you have 100 truck bodies and 100 wheels, and you can only make 5 trucks. So that means that you're only making 5 out of a possible 25. This is the possible. This is how many you make. So this is called the percent yield. And this means, and the formula is the actual yield over the theoretical yield times 100%. So for us, and again I got to erase, I'm sorry, keep this equation in mind. I'd write it down somewhere. So when I erase, okay, let me rewrite. The actual yield is 5 trucks. The actual yield. So my percent yield, percent Y, is 5. The actual yield divided by the total possible, the theoretical yield, which is 25 times 100. So when we do that, we get 20%. And that's how you calculate percent yield. All right, so we're going to do this, only we're going to do it with chemicals. So the process is the same. Instead of counting trucks and wheels, which are easy to count, we're going to count molecules or moles of molecules. So here's our reaction. 4 ammonia NH3 plus 5 O2 yields 4 NO plus 6 waters. And you're given the facts that 75.3 grams of ammonia, this point there, reacts with 100 grams of oxygen. And they want to know what the percent yield is if we get 60 grams of NO. So that's what the problem reads. You need to read the problem at 60.0 or 60 grams of NO and 100 grams of O2. So they want to know what the percent yield is. You've got to pick these numbers out of the written problem. So we'll start with our 75.3 grams of NH3. 75.3 grams of NH3. And we multiply by the molar mass such that the units cancel. That's 17.03 grams of NH3 per mole of NH3. You must show how you got this value here. I'm not showing it here because I don't have room. Then we multiply by the stoichiometric coefficient, 4 moles NH3 per 4 moles of NO, and then again by the molar mass of the NO, which is 30.0 grams of NO per mole of NO. And that gives us the theoretical yield if all the ammonia reacts. So this gives us 132.7 grams of NO, which with sig figs would be 132 grams of NO. Okay, now I do the oxygen. I calculate how much NO I can make from 100 grams of O2. Notice it's really important to put all my units in here. I'm going to change colors a little bit so we can keep track of the different things. The molar mass of O2 is 32.00 grams of O2 per mole of O2. Now I can do my stoichiometric conversion, 5 moles O2, and yes, I'm sorry, but you have to write all this out per 4 moles of NO. If you don't put all the units in, I will take off serious number of points. And the molar mass, again, is 30.0 grams of NO per mole of NO. There's a couple of calculations that I'm not showing that you have to show. That's this molar mass calculation here and here. So, and up here for the NH3. So I did 3 of those. So that gives me a value for the NO formed from 100 grams of O2, and that is 75.01 grams of NO. So this is the lesser amount. This is our theoretical yield right here, 75.01 grams. I cannot form this much NO. I can't form the 132 grams of NO. I didn't have enough O2 to form 132 grams of NO. So the O2 is the limiting reagent. It run out. And I label it. Well, let me restate that. The O2 run out. I formed less NO from the O2 than I did from the NH3. So I was able to form 132 grams of NO from the NH3 and 75.01 grams of NO from the oxygen. So the oxygen run out first, so it is the limiting reagent, and this is the 75.01 is the theoretical yield. Now I can calculate the percent yield. So I got to erase again. So where I'm at now is I have 132 grams of NO from the NH3 and 75.0 grams of NO from the O2. We decided that the O2 was limiting and that the 75.0 grams of NO was the theoretical yield. So the percent yield will be my actual yield, which is the actual. That's how much they actually formed, which is 60 grams of NO per theoretical yield, which is 75.0 grams, times 100, and that gives us our percent yield, which is exactly 80%. And I have 2 sig figs there. That's all you have to do with this. This is a percent unit on that 100 right here. I'll do another one on another video.